Hello, my name is Colton Chapman. I am a first-year environmental engineering master's student at the University of Kansas, working under Dr. Roundy. My project is incorporating climate uncertainty into water allocations in Kansas. I'm working with Richard Rockwell of KWO to update and upgrade KWO's current water allocation model. As you can see in Figure 2A, KWO's current water allocation model utilizes the 1950s drought climate. This kind of model is considered a stationarity model. And this model does not incorporate climate uncertainty and is in the face of climate change is not a very good model to use in the future. So the new model will incorporate climate uncertainty by utilizing CMIP5 data or CMIP5 projections from 34 different climate models. If we take some of these models and run them from 1950 to 2005 and then take the monthly averages and then compare those to observed streamflow monthly averages at different USGS gauges, as seen in Figure 3 and Figure 4, it can be shown that the model currently is severely underestimating average monthly streamflow. We can also evaluate the strength of these models by running a KGE analysis, as seen in Figure 5. It is also noted that the model does better during the colder months of the year and does worse during the warmer months of the year, as supported by the KGE analysis. We can then take some of these climate models and project them from 2006 to 2100 under different climate emission scenarios, RCP 45 and RCP 85, as seen in Figure 6 and Figure 7. Evaporation is also something important to consider, as evaporation is one of the biggest loss leaders in reservoir storage in the state of Kansas. If we were to run a model from 1950 to 2005 to simulate evapotranspiration, and then take those same models and a couple more and evaluate them from 2006 to 2100, we can see if there's if the models are projecting a difference in evaporation for the next century. And Figure 8 shows that some models are predicting more while others are predicting about the same evapotranspiration. We can also see in Figure 9 the projected precipitation from different models and underneath or under different climate emission scenarios, RCP 45 and RCP 85. And Figure 9 is located at Tuttle Creek or Tuttle Lake in Kansas. We can then also take KWO's data for their evaporation at Tuttle Lake and compare it to what the model at one of the models is showing evaporation should be from 1950 to 2005 as a on a monthly average basis. In Figure 10, we can see that the model is again severely underestimating evapotranspiration in this case. It's severely underestimating it. So from now, and the results show that the models need to have a climate forcing element to them. So the next steps are to continue to evaluate the rest of the climate models underneath CMIP5 and to incorporate different climate forcing techniques for the historical period, and then use those same to project out to 2100.